We now understand that a sample of gas can exhibit ideal gas behavior under most conditions. But if the gas exists at particularly high pressure or low temperature, this will behave as a non-ideal gas, because the volume of the particles and the interactions between them can no longer be ignored. But how then are we supposed to do calculations for these kinds of gases? We will need an equation with corrective factors that account for these two parameters the non-ideal gases display. That equation is the van der Waals equation. We can see that it is essentially a modification of the ideal gas law, PV equals nRT, but there are corrective factors for the two parameters in question. These two terms can be considered the ideal gas pressure and the ideal gas volume, because treating these terms as P and V would give us PV equals nRT. But we can see that the actual pressure must be a little bit less than the ideal gas pressure, because to get the actual pressure from the ideal gas pressure, we have to subtract this corrective term, AN squared over V squared, that accounts for the attractive forces between the particles. These attractive forces slow the particles down slightly, which reduces the pressure, making it less than what we would expect for an ideal gas. The actual volume must be a little bit more than the ideal gas volume, because to get actual volume from the ideal gas volume, we have to add this corrective term, NB, which accounts for the volume of the particles. The ideal gas volume ignores this volume, so to get the actual volume, we have to add this term to the ideal gas volume, or as written here, we subtract the corrective term from the actual volume to get the ideal gas volume. With this equation, we are equipped to do calculations that will give more accurate results when looking at non-ideal gases. In these corrective terms, we see moles and volume, but also some constants, A and B. So what are these? These are constants that are specific to an individual substance, as each substance contains molecules of different sizes. Here are some examples of values for A, which corresponds to the attractive ability of a particle, and B, which corresponds to the size of a particle. How different will our calculations be if we use the ideal gas law and the van der Waals equation for the same sample of gas? Let's move forward and compare these two approaches.